Hi.
How are you?
Good.
Good. Did you want to work on the homework together, or do you have questions about something previous?
Hold on. I'm sorry, what? I just put in earbuds.
Okay, I said, did you want to work on the homework together, or do you have questions about yesterday's notes?
On the homework,
Okay.
I need help with like 3 through 14.
Okay. All right, let's work on that then. So you did okay on number 1 and 2?
Mm-hmm.
Great. Okay. On number 3, and I didn't really talk about this in class. This is a discrete graph. And you'll notice on our notes, it said yesterday we spent a predominant amount of time in class going over the domain and range for continuous graphs. And I didn't really touch base too much on a discrete graph, which, remembering from our definitions, a discrete graph is one that's non-continuous, like the random dots as pictured on numbers 3 and 4, and then 5 through the remaining are, the continuous graphs where the dots are actually connected. So for number 3 and 4, to identify the domain and range, and my paper isn't really big enough for me to write down every single one of the ordered pairs, but that's what you would want to do. So I'm going to write them to the side. Okay, so this first dot over here in the far left over here, the ordered pair for that's going to be 1, 2, 3, 4, 5, 6. So negative 6 and negative 1. What did you say?
Negative 6 and negative 1.
Yes, ma'am. So the negative 6 would be the domain, part of the domain, and negative 1 would be the range. So, and then this next point is going to be negative 1, and then 1, 2, 3, 3. So negative 1 would be the domain, and 3 would be the range. Does that make sense?
Mm-hmm.
And then the range, the domain and range on the next one, that's 2, 0. So 2, 0. And then this point here, it's going to be 1, 2, 3, 4. So 4 and negative 2, I believe. And then the last point is 1, 2, 3, 4, 5, and a positive 3. So that's the domain. It's a very definite, defined domain. Does that make sense?
Yes.
Okay. So number 4 would be the exact same way. Do you
Okay.
want to work that one together, or are you good to do that one? You want me to move to the rest?
You can move on.
Okay. Um, now, the domain and range for number 5. This is a continuous graph. So what we have to picture in our heads is the fact that this is just a small picture of something that's going on globally on a coordinate plane that extends forever and ever and ever into from negative infinity all the way to infinity. So we're really going to be using our arrows to the end behavior of those arrows to kind of figure out where we're going. And obviously, if you're just looking at this just from a left-right standpoint, it's going to go on forever and ever and ever, isn't it? It's never ever going to stop. Does that make sense?
Yeah, I think I get it. So
Oh,
are both of them like all real or
yes,
repeating?
that's perfect. All real numbers on this one. And the video that I'm going to be posting tomorrow for kind of a review before the quiz on Friday, he does it a little bit differently. Everybody does it a little bit different. And I may be talking about that, like how to write the stuff, like how to write the domain and range. There's a variety of ways to write that. Like some people actually would write the domain and range for that one. I'm going to erase this and show you. Some people would actually write the domain and range so that it actually looked like this. Like there's a parenthesis and it says negative infinity to infinity, and they would just close it to say that all numbers are included in the set. Because you know how like over here we made it a set? They continue to make it a set, but it's an ongoing set. Does that make sense?
Kind of.
Um, uh, this just means that the first number is negative infinity and the last number is positive infinity.
Okay.
But if it's easier for you to just remember all real numbers, that's fine too. But some people, I just don't, I guess I want to kind of introduce a variety of ways to list the domain and range so that when you see it in a different way, it's not overly confusing. So, but all right. So the domain on this one, it looks like, we have definite stopping point. If I'm looking at the X, so I'm looking at what's happening with the graph in the X origin. Like if I were to squish that closed onto the X axis, it looks like everything to the left of this line right here, which is 1, 2, 3. Is that 4? Or is it 5? 1, 2, 3, 4. It looks like it's
Yes.
4. It looks like everything to the left of that is going to be part of the domain. So to the left means they're negative numbers. So X is going to be less than or equal to 4. Because nothing over here is possible to be an X, is it?
No. Okay, I get that.
Okay. So now the range for this one, what we have to picture is the fact now what we're thinking is this line right here is going to continue on forever and ever and ever and just keep going up and up. Yes, it's headed west or to the left, but it's also going up. And the only part that you're thinking about with regard to the range is up and down. It doesn't matter that it's going toward the west or that it's going left. What we want to think about is it going up or is it going down? And it's actually going up and down toward infinity forever and ever and ever. So on this one, the range is all real numbers. Because yes, it is going toward the left, but it's also going up and it's also going down. Like this leg here is going down into negative infinity, and the other leg over here is going up into positive infinity. Is that, or were you confused by that, or are you good with that?
I get it.
Okay, good. All right, so number 7, with regard to the domain, we're thinking about what is the graph doing horizontally or left and right. So the graph looks like, because of the end behavior, the little arrows that are on the ends here, they're telling us that it's going to go on and on forever and ever to the left, which is negative infinity, and to the right, which is positive infinity. So for the domain, all real numbers. However, for the range, it looks like we've got a top point, a maximum point up here, which is 1, 2, 3, 4, 5. And it also looks like we've got a minimum point right here, which is -1 on the y. So our minimum is going to go on the left. And so y is going to be greater than, or no, my bad. -1 is going to be less than or equal to y, which is less than or equal to 5.
I'm still confused on how do you know like less than or equal to or greater than equal to?
Okay. Great question. And so I'm gonna also show you the other way to write it so that you can kind of safeguard against that. Okay. So if -1 is the minimum value, the minimum, it's not going to be any less than -1. So -1 is, so y, so that means y is always going to be greater than. And remember, with a greater than symbol, the bigger number has the bigger part open to it, right?
Mm-hmm.
Like that, So you know that y is going to be bigger than -1. It's going to be either -1 or bigger than that.
Okay.
So your big mouth would be open. The big mouth of the greater than less than symbol would be open to y. However, it's not going to be bigger than 5. 5 is going to be the very biggest that it's going to be. So that greater than part, or the mouth, the bird eating the bigger number, is going to be open to the 5, because it's y is going to be less than that.
Miss
I
Sparks,
get it.
can you scroll up just a little bit?
Yes, I can scroll up just a little bit.
I just joined and I had questions on 3, 4, and 5.
Okay. I didn't I just went over 3, and I went over 5. But just to kind of give you a quick review, we didn't actually do number 4 because Courtney said, based on the instruction that I gave her for 3, she could handle 4. But basically what you're doing for 3 and 4 is the same thing. You're writing down all of your ordered pairs, which I kind of did to the left there. And all the X's would be the domain, and all your Y's would be the range.
Oh, okay.
So that's how you do a discrete graph. It's very much like number 1 and 2. And then let's see. And then Courtney, on back to number 7 for just a second. If you wanted to, remember how I showed you the negative infinity to infinity on number 5? The second way to write the range for 7, and I can talk about this, but if this is confusing, I don't want to do it. If it includes -1, you can actually write a bracket like that, and it includes 5, you actually don't have to write the less than and equal to symbols. You can actually write this bracket looking thing. And if it includes it, you write a hard bracket. And if it doesn't include it, you write just a parenthesis. So you could write it like that.
So if it doesn't use parentheses?
Just a regular curvy parenthesis. And you do that for the negative infinity and infinity also. So the curves go with if it doesn't include 1. And I'll show you on number 8, because it doesn't include something there. Okay. So I'll show you there. But if the less than symbols confuse you, you can do this notation. So what I'm going to probably do tomorrow a little bit is spend some time on the various notations that you can write, because unfortunately, as confusing as this is, and that's why I wanted to stick with one, and this probably is the most intensive way to write it. I wanted to kind of stick with one of them. And then once we kind of grasp the idea of domain and range, we'll then move on to the various ways that it can be stated from a syntax point of view. But on number 8, Courtney?
Yeah.
And Mary Faith, are you still there? You still hanging with us?
Yes.
Okay, good. All right, the domain here, okay, we do have limited domain and range because the end behavior on this graph, they both have ends to them. So it's going to be more of a finite domain and range. And the beginning point over, because you read a graph from left to right, so the beginning point that we have is -1, -2. Like that's the ordered pair right here. That's -1, -2. So -1, so what we know is the smallest x value is going to be -1. So, and the largest x value is going to be 1, 2, 3, 4, 5. So it's going to be 5, 3. And then this over here was -1, -2. So my domain is going to be -1 is less than or equal to x. But you'll note that this one is open. So it's just going to be less than 5. Can you read that okay?
Yes.
Okay, good. It's kind of messy, but all right. So wanted to use the bracket syntax. This one would look like a hard bracket because it includes -1. Then you would use a comma, write down a 5, and then a soft bracket or a parenthesis. So that indicates that that the 5 would not be included.
Oh.
Okay, does that make sense? Is that easier for you than the less than equal to?
It's actually harder for me.
I don't know.
Okay.
I'm just not getting everything. I get it.
Oh, okay.
But how do you know which point is domain and which point is range?
The domain is the x's, and the range is the y.
Yeah.
So now for the range on this one, -2 is less than or equal to y. And this one, once again, that circle is open, so it's just less than 3.
So you could
So
basically
on this one, no, go ahead. I'm sorry.
you could basically just fill in the same formula as the domain for the range, just the y and the, like, you do the same signs.
Yes. I mean, on this one, you would for sure. Yeah. Sometimes if the graph is facing different or something like that, it might be a little different. But for the most part, yes. But there down below is the way that you would write it if you just wanted to use the bracket syntax versus the less than, greater than syntax. Okay, so for number 9, we have a starting point over here for our x's and 1 over here. So the starting point is 0. So 0 is going to be less than or equal to x. which is less than or equal to 1, 2, 3, 4, 5, 6. And for the range, that's our up and down. We have a starting point at 1, 2, 3, -3, and a top point at +3. So our range would be -3 is less than or equal to y, which is less than or equal to 3. Number 10, you kind of are looking at your endpoint behaviors here, and you see that this graph is actually going up and to the right all the way into infinity and never ever stops. And on the left, it's going down and to the left into infinity all the way, never stopping. So even though it's moving more quickly up and down, it's still moving out into the right and down into the left. And so you're always thinking about, for domain, you're always thinking about how is the graph moving horizontally? Is there ever going to be an end point? And no, there isn't. So the domain here is all real numbers and the range is all real numbers. For number 11, the domain is what is this graph doing? How is it acting from a horizontal standpoint? And it's going to continue on all the way into negative infinity. That's all those numbers to the left right here. All of these. It's going to keep going out, 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 out. I mean, it's rising, yes, but it's also moving westward or to the left, and as is this side moving all the way that way. So your domain is going to be all real numbers because every x is a possibility. However, with your range, there is a minimum point. If I'm starting from bottom to top, none of these values down here are a possibility. My very first y that's a possibility is -2. And then from there, it goes all the way to positive infinity. So y is greater than or equal to -2.
Wait, so it's -2y? Oh, you flipped it. Okay, never mind. Never mind.
Well, I wrote down the -2. And if you wanted to write actually in bracket notation, it would be -2 with a hard bracket to positive infinity with a soft bracket.
Could you put -2 is less than or equal to y?
No.
Okay.
Well, I see what you're saying. Yes, you could. So if you wanted to write it like this, Mary Faith, like this, like that, you wrote it like that?
Yeah.
Yeah.
I'm starting to understand it more.
Yay! It just takes some practice. I mean, I still, I'm right there with you. This was one of the, like I told you, everybody in class yesterday, that and mapping. It took me, I just kept having to study it and study it and study it.
Mapping isn't that confusing for me, but this graphing is a little bit, but I get the infinity.
Yeah, some graphing isn't that bad for me. I still would rather do an equation, but but the domain and range for a long time was more of a difficult for me to always grasp what it was doing, But it, like I say, it just took time. But number 12, we have some stopping points for our domain. 1, 2, 3. So it's going to be -3, is less than or equal to x, which is less than or equal to 2, 3. And then for our range, 1, 2, 3, 4, 1, 2, 3, 4. So it's going to be -4 is less than or equal to y is less than or equal to 4. And then this one is going to be all real numbers for the domain because it's going to continue on into infinity, negative infinity, all the way into positive infinity. But we have some stopping points for our range. Our minimum point is -2. It's less than or equal to y. And our largest or maximum point on the upper end of the scale is 1, 2, 3, 4 is less than or equal to 4 for that one. And for number 14, our domain is any x is a possibility forever and ever and ever. But our range is always going to be -1. Because y is always -1.
I got all those right.
Yay! Good job, Courtney.
Isn't that the positive one?
This right here is down 1.
I thought it looked
below.
like x-axis was below that line. I couldn't really tell.
Can you re-explain number 12?
Oh, you know what? You're right. You're right. This is probably the x-axis, isn't it? You're right.
Really tell us.
Yeah. I couldn't tell the x-axis from the line.
It looks so similar.
Miss
I know
Sparks,
they
could you
do.
explain number 12?
Re-explain number 12? Is that what you
Yeah.
asked? Yes, ma'am. I
Yes.
sure can. The domain is what is going on horizontally. And so I don't have any numbers here and no numbers here. It's only these numbers in between. So the beginning is -3 right there.
Mm-hmm.
And the biggest that it's going to go is +3 on the other side.
Okay.
So from -3 to 3. And then the range is what's going on vertically. And the biggest that it's going to, or the least that it's going to be is -4. And the biggest that it's going to be is +4. And it's all the numbers in between.
Okay, that makes sense now.
Okay. Yes?
Instead of writing negative infinity to positive infinity, we just write all real numbers.
Yes, you can. I'm showing all the different ways that you can write it. You can write, this is not the answer to 15 and 16, but you can definitely write negative infinity to infinity. You can write all real numbers. These are two different ways that you can do it.
And for 1 and 2, I was not here. Did you just graph the point as like a discrete graph?
Yes.
Okay.
I actually didn't fill those out. But yes, you would just graph them as a discrete graph. Good question. And then 3 and 4 are discrete graphs, and then the rest of them are continuous graphs when we're working on those. Okay, I'm sorry. I feel like I interrupted somebody. What was somebody else's question?
Oh, Miss Sparks.
Yes.
When you do the range on number 4, is it okay to do like 5, 5?
For which one?
Number 4, do you only write a number once?
Yes. I don't see one that's repeated. Which one's repeated?
Number 5 as range.
Where?
I think.
On this one? On number 4, on the homework? Or on the number 4 for homework? Up here?
Hold on,
This one?
I think I did something wrong.
Because I don't have a number repeated for mine, but maybe I did something wrong, you know. Because I would have this one, 1, 2, 3. That would be 3, -2. This one here would be -2, 5. And this one would be 2, 3. And then 0. Oh, you know, the other one is -5, Courtney. One is 5 and the other's -5. And -6. Does that make sense?
Mm-hmm.
Maybe you didn't put a negative or you can't see the negative on your thing. But 1, 2, 3. Any more questions? Y'all want me to keep working through them?
Yes, ma'am.
Okay.
Sparks.
Yes.
For those questions that have the points on them, like the filled in circle and the one that's not filled in, do we need to use those different grouping symbols?
Let's see.
Number
Like number 8?
Yes, ma'am.
Okay. You can either write it. I don't know if you can see my horrible writing here, but I'm going to circle the different answers. This one is red. -1 is less than or equal to x is less than 5. That's one way to write it. And then the other way to write it is with a hard bracket, -1, comma, 5, and a soft close bracket. You do not have to write it both ways. You may pick whichever one makes the most sense to you. And the same for the range. Whichever one makes the most sense to you is the one that you should pick.
Okay.
So, okay?
Why isn't
It's just
the second one less than or equal to? It's just less than 5.
because the circle is open.
Okay.
So it's not included.
All right. I understand now.
Okay. All right. Any more questions on those? Those are all really good questions. All right. Then I'm going to keep working through this. Okay. Determine whether the relation represents a function. All right. So what we learned yesterday is the x's cannot repeat in order for it to be a function, because then it wouldn't, if we were to graph them, it wouldn't pass the vertical line test. So let's go through and check our x values. We have -2, 2, 3, 4, 5. None of those x's repeat, do they? So that would represent a function. Now on this one, we have a -3, a -2, a 1. Oh, we got another -3 and a 0. So this has, these two ordered pairs have the same x value. So this would not be a function. All right, number 17, given in a table format. -2, -1, 5, 4, -1. We got a repeat. So this would not be a function. Okay. So now for number 18, like I told y'all yesterday, for me, the mapping, I need to legit write down the ordered pairs. But I'm getting better because I'm going to say off the bat, I'm guessing before I write down the ordered pairs that this is not going to be a function. But it looks like 6 goes to 3, but it also goes to 5. So that would already be a repeat. And 7 goes to -4. And 8 goes to 1. So these two repeated, so it would not be a function. On number 19, what I'm looking for on it is a vertical line test. So basically, could I draw vertical lines on these? And does it pass the vertical line test? And it does. No 2 points are on the same vertical line. So this is a function. Now this one, vertical line test, oh, it's already failing because it's passing at 2 points in several vertical line tests. So it is not a function. So no. Now on this one, I'm drawing my vertical lines, and this one looks like it's going to pass all the way through. So it is a function. Well, this one definitely not going to pass because that is a vertical line on that section of the graph. So no. Does that make sense to you guys? And do you have any questions about anything that we've gone over Friday or Monday?
Could you do 1 and 2, please?
Yes, I could. Okay, so identify the domain and range and then represent the relation as a table, mapping, and graph. Okay, so the domain is going to be all the x values. So -5, -4, -2, 0, and 1. So -5, oops, that's a pretty -5. It looks like an 8. Make it a little bigger and see if that helps me write. -5, -4, -2, 0, and 1. So now my range is all of the y values. So 4, -1, 1, 4, and 3. So, and you want those to match up because this is a table format, and you always want your x and y values to match up as if they were within the ordered pairs. Does that make sense to you guys?
I thought when we were listing them, we didn't have to repeat the numbers. Or was that only?
Did I repeat one? Did I repeat one?
Yeah, 4.
Ah, I did. Yes, you're right. Thank you. I think I just probably didn't notice. You do not have to. Okay.
The ones that we put in least to greatest, order they're in.
Oh, really good question. It's probably a good idea to do them in least to greatest. So I guess what you would want to do then is if you wrote them down, and then you would want to go back and do -1, 1, 3, and 4.
Okay. Thank you.
I wouldn't necessarily count it wrong, you know. But those are really good questions. Okay, so for the mapping, -5, -4, -2, 0, and 1. So -1, 1, 3, and 4. So -5 goes to 4. My mapping's going to be pretty. -4 goes to -1. -2 goes to 1. 0 goes to 4. And 1 goes to 3. And then to plot them, 1, 2, 3, 4, 5. 1, 2, 3, 4. And then -4, 1, 2, 3, 4. And then -1. -2, 1. 0, 4. 1, 3. Does that help, Eli?
Yes, ma'am.
Okay. And then the domain on this one, there's a repeat on this one. I've got a -3, so I don't have to write it again. And praise God, those are all in order. But my table, I do have to repeat everything. I have to write it as is. And then my range, -4. And then my next largest is a 0. And then my next is a 2. And then my next is a 4. And my next is a 5. Zero, 5, and 4. And -3 goes to 4, but it also goes to 5, which makes this one not a function. -1 goes to 2, 0 goes to 0, and 2 goes to 4. And then to plot those, 1, 2, 3, 1, 2, 3, 4. -1, and then up 2, 0, 0, the good old origin. Then 1, 2, 3. 1, 2, -3, 5. And 2, 4. Did I miss one? No, I didn't. Here they are. I was like, and this is our one that does not pass the vertical line test, which shows us that it's not a function. That wasn't a question. I just wanted to go ahead and talk about that a little bit. Any other questions? Like on any of the homework or class notes or any of that stuff that we've had for the past, like Monday or on Friday? Everybody's quiet. So you all feel good about it?
Yes, ma'am.
Okay.
Kind of. I'm still a little bit confused on the graphing where you have to put domain and range.
Oh, you are?
A little bit. I'm starting to understand it.
Okay. Do you want to look at these some more?
Yes, please.
Or
Is it like specific ones that'll be on the test quiz? Or is it like
I think, like, I don't know if you noticed this, but even some of the ones, these are very similar to the ones that we did on the in class yesterday. Did you kind of notice that they were pretty similar? Well, they're going to be very similar to the ones that you're going to have on the quiz on Friday.
Okay.
Okay. So how do you feel the ones that we've done today and yesterday?
I somewhat understand it. It's, I guess, just the order of like how you put it. So, like, say on number 13, why is the domain just the I don't know.
All real numbers?
Yes.
Okay. Well, think about what the graph is going to do horizontally, the X's and the Y's, or the X's. I'm so sorry. So can you think of an X that's not going to be on there? That's this line right here.
No.
And this tells me it's going to keep going, right?
Yeah.
So that would be all real numbers because this is just the X's.
And how do you solve for the range?
The range is just the Y's. So that's this. So are any of the Y's up here a possibility?
No.
Are any of the Y's down here a possibility?
No.
So what you're looking at, let me erase some of my scribbling here so that it doesn't look quite as bad. So what we're looking at then is this is the lowest that the Y dips, that the graph doesn't dip any lower than that. So that's going to be this side of the range. But the Y's don't go any higher than this. So that's going to be this side of the range.
Okay.
So what's that minimum point and what's the maximum point on a graph like that? And like 12 also. Because for 12, the range didn't go below or above this. It's those Y's that are in the middle. And remember, that's just this axis right here. You're not even thinking about the horizontal. You're only thinking about the Y coordinate for the range. Okay, and the domain is just the X coordinate.
Okay, I think I understand. So it's the same thing with the X as well.
Yes. The domain is the X, and what you're thinking of are what are all the possibilities that X could be. You're not thinking about the Y. You're not thinking about what's it doing in the up and down way. You're only thinking about what it's doing in the left and right way for domain.
Okay. Is this an open note quiz or not?
Not this one.
Okay.
Next Friday is. I'm not sure if the notes would help. Would they help? Do you think the notes would help this week?
I mean, hold on. No, I guess not. You're right.
I mean, I guess as I pray through it, if I get a predominant amount of you guys that tell me tomorrow that the notes would help, I think my fear is they'll add to the confusion as to help. And my prayer as a teacher is that whatever I have you guys do, it's always going to help and not hinder, you know?
Yeah.
So we'll just we'll see how we're working in class tomorrow. and see how that goes.
Okay.
Eli, are you still with us?
Yes, ma'am.
Do you feel like notes would help tomorrow? Or Friday, I'm sorry.
Maybe.
Or be more confusing? Okay. Well, I mean, I'll take a poll because, like I say, if y'all were to look at all this stuff and then be confused, it would make me sad because y'all are working really hard to understand this. So, hey, Kennedy.
I didn't understand this yesterday.
You didn't understand it yesterday, but you get it better today?
Yes.
Well, praise the Lord. I'm glad to hear that. How about you, Eli? Are you getting it better? You were doing good in class yesterday, though.
Yes, ma'am. It seems a little bit easier.
Okay, good. I'm glad. So we'll see how class goes tomorrow, and I'll kind of take a poll as to see if y'all think notes would help. But sometimes I feel like with domain and range, y'all can look at that, at all the little different, 0 is less than X is less than 6. And sometimes you start looking at that and it freaks y'all out more than it helps you. So anyway, but do you have any other questions?
No, ma'am.
Kennedy, how can I help you?
Can you go back over 3 through 8?
3 through 8?
Yes, ma'am.
I can.
Bye, Miss Sparks. Thank you for helping me.
Oh, you're welcome, Mary Faith. Have a blessed afternoon.
You too.
Thank you, Miss Sparks.
You're welcome, Eli. See you tomorrow. Have a blessed afternoon.
You too. Bye.
Bye. Okay, Kennedy, for number 3, this, I didn't actually go over one of these examples yesterday in class. It was a little bit more of some of the stuff that we did on Friday, really, but this is a discrete graph, which means it's not connected. So, what you would do for these, and my writing's kind of messy on this, but I wrote for number 3 to the left, you'll see those are my ordered pairs that I wrote down for all of these points on that coordinate graph. And so then I took all of my X values, and that was my domain. And I took all of my Y values, and that was my range.
Gotcha. Thank you.
And the same for 4 as well. You're welcome. Does that help?
Mm-hmm.
Okay. But that's all you had to do on those. And I feel like did we do that on Friday?
I
can't remember.
Maybe.
Oh, okay. All right. Maybe we didn't. I can't remember. I don't remember what the notes looked like. But the domain and range for discrete graphs are very much like just looking at a set of ordered pairs and just pulling the X's or and for the domain, and then just pulling the Y's for the range.
Okay.
The Y coordinate. Now, for number 5, with regard to the domain and range, what you want to do on the domain is really, if it just kind of do away with what is the graph doing going up and down. You're only looking at the characteristics of what is this graph doing from left to right or east to west, or however you want to think about it. So for number 5, the end points indicate that it's going to go on forever and ever and ever.
Okay. So when it's the arrows, it's just real numbers on both sides.
Yes.
Okay.
9 times out of 10, that's what it's going to be. Except, and I say that when it's a line, it's definitely that. But you've got number 6. That's not necessarily the case for number 6, because this one, when we're checking out what's going on left and right, hang on. Oh, that's really big. I was trying to make it bigger so that my writing wouldn't be quite as ugly. So I'm going to erase these. talk about it a little bit more. Remember, the domain is what's going on the x-axis. This part right here. Nothing else but what's going on there. So, is there anything going on this side?
No.
There's nothing going on there. However, when I hit this point right here, which is 1, 2, 3, 4. When I hit 4, there's stuff starting to go on. And it moves all the way this way into negative infinity, because over here is negative infinity. So what that tells me is that y is going to be less than or equal to 4. Because that's all the x's, and all I'm dealing with is that x-axis. Okay?
Okay.
Now, for the range, that's going to be, what is this graph going to do up and down? Like what is it doing with regard to this axis right here? And however, we only have a small picture of something that's going on globally into infinity. This actually is going to continue forever and ever and ever in this direction, positively into infinity. Okay, so this is just going to keep getting bigger and bigger and bigger and bigger as it goes out. So for y, there is no everything is a possibility, because it's going to keep going out into positive infinity on this side and negative infinity on that side. So it's all real numbers. Does that make sense?
Mm-hmm. But why did you put the y in the main file?
Oops. That I didn't mean to.
Okay.
Good catch on your part. I'm very sorry. I meant to put X. I'm so sorry. Especially this stuff can be so confusing, so I hate it when I write down things wrong. Did that help? So sorry about that. Okay, that makes sense to you?
Mm-hmm.
Okay, good. All right, now on number 7, I have all real numbers for the domain, because just like on number 5, we've got these arrows on the end that are kind of showing us what's going on from an east-west or left-right direction. So it's going to, from here, all of this stuff is going to continue on into infinity. So all real numbers are the possibilities.
Okay.
But the range, it's got some starting and stopping points. And that bottom point is -1. But the top point, it's not going to go beyond 5. In the positive direction. So it's -1 is less than y is less than 5. For number 8, for the domain, this is a finite graph in that this point right here, which is inclusive, is -1, -2. So for the domain, -1 is going to be the smallest number on this graph that x can be. And over here to the right with an open circle, which means it's not going to be included at the end point over here. That's what the open circle means. But it stops at the point 5 and 3, even though it's not included. And the colored in circle is included. So -1 is less than or equal to x, and less than 5. Not equal to, it's just less than because it's not included. And for the range, -2 is the y coordinate, so it starts there, and y is less than or equal to because it does include that point, but it goes all the way over or up rather to the point 3, but it doesn't include that point because the circle is open, so it's just less than 3.
Okay.
You want to keep going?
I think I got him.
Oh, good. Good. I'm very glad. That's awesome. Do you have any other questions about anything else?
For the second worksheet, I got all yeses.
Oh, for the mapping function one?
Yes, ma'am.
I think there was a couple no's.
Okay.
Let me see. And I may not, it may take just a quick second. I forgot. I need to. That was the mapping one, right?
Yes, ma'am.
I need to, I don't think let me see if I have. Hold on for just a minute. I'm going to see if I can find that worksheet. I'm really sorry.
It's okay.
I can't remember. Yay, I think I do have it. Praise the Lord.
Yay.
I know. I'm gonna share it, and will you tell me if I picked the right one? Does that look like it?
Yes, ma'am.
Yay. And like I said, this is the one that I'm like, oh, I got to write them all down because the struggle is real. So for this one, I have 1 7 or 1 0. My bad. Seven, 8, 8, 8, 9, 1. So there are no repeats on that one. So it is yes. On this one, 0, 5, 3, 5, 5, 9, 6, 9, and 9, 5. So it is. Can't remember. There was one that wasn't. I think it's number 5 because 3 and 4 both were. And I have 3, 3. The repeat is 3, 3, and 3, 9. And I think that's right. And then the last one looks like it isn't. So let's just look and see if we can't find the repeats for number 8. We've got 0 goes to 2. 1 goes to 4. 4 goes to 2. Oh, here 9 goes to 1 and 9 also goes to 2. So the repeat is 9.
Okay.
Does that make sense?
Yes, ma'am.
That I know those are tough for me too. And like I said in class yesterday, a lot of times I either have to write every ordered pair or I try to look for, is there from one of these lines here, is there two lines going from a number here
Mm-hmm.
to, two different numbers? Like, is two lines going from it? Does that help? Here's
Yes,
the
ma'am.
answer key. So did you want to see the answer key on the other one too?
No, it's okay.
Okay. Because I actually have it. It's, well, no, it's not fairly close, but did you get to see my answers?
Yes, ma'am.
I could scoot. Oh, okay, good. And did you have any other questions?
I don't think so. Thank you.
It's just, I feel like it's one of those things where practice makes perfect.
Yeah.
Unfortunately for this. And like, well, I think we went through, what did we go through? Like 12 examples yesterday, and we've got like 14 or 15 today. So. But okay, if you need me, you can email me.
Gotcha. Thank you.
You're most welcome. Have a blessed afternoon.
You too.
Thanks for coming to Math Lab.
No problem.
All righty. Bye-bye.